Hello, everyone. So, as most of you probably know, some really exciting things are happening in the world of renewable energy, and those changes have some interesting effects, and I'm going to talk about how those effects are visibly showing up in electrical demand patterns in California. So, before I get into that, I'm going to talk a little bit about myself. Like Ben said, I'm a data analyst. I'm one of the co-organizers for the Data Visualization DC Meetup group, along with Ben, and I wrote a book about energy storage and the future of what energy consumption will look like, because it's a really cool and important topic. So let's talk about the duck curve. The duck curve. This is a chart of daily demand for electricity in California on March 3rd or March 31st, forecast out. And this image was created in 2013 because a couple of researchers realized that the falling cost of renewable energy was going to create some complications for the grid operators who have to make sure that the supply and demand of electricity match at all times. If there's too much supply or not enough supply, the electrical grid will either shut down, catch fire, explode, or maybe all of those. So it's really important that the supply and demand of electricity match very closely. So it was a very interesting time period for a couple of years because policymakers who were looking at the electrical grid would talk about the duck curve and would talk about having to strangle the duck because this chart looks a little bit like a duck. So I'm going to go through a brief history of the duck curve and give you a sense of how the electrical grid has really changed over the last 10 years. And then I'm going to talk about visualizing the duck curve and give a couple of tips about how annotations and flourishes can make data visualization more appealing. So in 2008, there was some research put out by the National Renewable Energy Laboratory about what the effects of solar photovoltaic, what the effect of solar panel market penetration was. And they looked at it and did some modeling, proprietary tools, not R, unfortunately, though these days they probably would use R. And they looked at it and they realized that there were going to be some pretty big issues during the day in terms of the maximum load actually decreasing during the day. A few years later, the California grid operators realized that this was actually going to be an issue, and they published this chart in 2013, and they gave it nice annotations, and people started referring to it as the duck curve because it looks a little bit like a duck. You've got the head, your wings, tail, and the interesting thing here is that the 2012 data, that's typically what hourly energy demand looks like. People, they wake up in the morning, and then as they start their day, they use more energy, and then during the day it tapers off a little bit while people are at work, and then in the evening everyone gets home and it ramps up until people start going to sleep. What large amounts of solar energy do is they overproduce during the day, which means that the grid no longer sees that demand because it's all behind the meter on people's houses. So instead of consuming electricity from the grid, they consume their own electricity from solar panels. And so the grid doesn't have to supply that, which means that the grid operators actually see their energy needs decrease throughout the day and then ramp right back up. And that evening ramp, the neck of the duck, is really hard for grid operators to deal with because it's hard to get electrical generators, especially the monstrous ones, the very large ones, gigawatts of power, that's very hard to do. 1,300 megawatts, 13 gigawatts. If anyone's a fan of Back to the Future, 13 gigawatts, that's enough to send the DeLorean back in time more than 10 times. It's a lot of power. And so people were calling it the duck curve. So now the question is, did the duck curve land in California? The charts that we were looking at were just historical data with forecasts. So let's actually pull some real data. So the Energy Information Agency in the US has a lot of open data around energy consumption, and some very generous folks wrote an R package that is an API wrapper for the EIA Open Data. And so there you can actually go online to EIA.gov and get a free API key and just download this. You can also download it manually. So here we downloaded the data and just looked at the first couple. And in this case, it's an hourly time series of demand in megawatts. So on July 1st at 1 a.m., there was a demand for 31 megawatts in California. Time zones. So the data is provided in UTC 0, but California time is 8 hours offset from Greenwich Mean Time. So we're going to have to adjust and set the system environment to LA time. It probably would be, or it is possible to just change the formatting and time zone of the data set, but setting the system environment makes a lot of things work better by default. So what does a day of this data look like? So here I use dplyr to filter out a single day, the 31st of March in 2016, early in the data, and then I plotted it with the base R plot function. And you can see it's pretty boring. The chart itself is relatively unexciting. So let's use a better tool. Let's use ggplot. So ggplot is the grammar of graphics library that allows for much better plots with better formatting, and it allows more powerful charts. So you can do a lot with plotting in base R. It's very functional. But if you want something that's both very extensible and very customizable, ggplot is a better library. So here you can say it's the same chart as we had before, but now the formatting is better and we have color options. So let's take a look at multiple years of data, because if you recall the duck curve chart, it had several different years of data. So I'm going to use dplyr here to extract the year, month, date, and hour from the data set. So now you can see it's the same data set, and we've extracted and added the year, month, day, and hour. And then we're going to filter and plot it. So we're going to do the same thing. I'm going to filter using dplyr to get the month, or to only get data points and observations that have a month 3 and day 31. So that should be the 31st of March for every year in our data set. And then we're going to plot it with ggplot. And here we're going to add the Lime geom. And here, if we add group year and color factor year, we'll be able to split them by year and have a different color for each. I'm also adding just some formatting for the chart. Let's see what it looks like. So that's plotting multiple years, and you can see. So you've got 2016, 2017, 2018, 2019, pretty much descending order for most of this. And you can see that over time, the load has definitely decreased, and the belly of the duck is a little lower. 2019 here, so this is March 31st, looks pretty low. But let's jump ahead to New Year's Day, so we have a little more data. So now I think it really starts looking like a duck. Here we're just doing the same thing with the plotting, filtering with dplyr for January and first day of the month. So that should be January 1st of every year in our data set, which is 2016, 2017, 2018, 2019, 2020. And you can see that overall the energy usage has decreased with most years, but the place where it's really decreased a lot is in the belly of the duck here. There, it's come down a lot, and this is putting some real challenges on grid operators wherever there's a large amount of solar, because that evening ramp, it's really tricky to start up large generators large power plants, gas plants, some of them like nuclear plants, you don't shut those off. And so there, if the option is shutting off a nuclear power plant or just rejecting the solar energy, that solar energy will be curtailed. And curtailment means that the energy isn't accepted on the grid, it's just wasted, which means that instead of that solar power being consumed and used to offset carbon emissions, it just gets wasted. So there, if grid operators can manage this better, they can curtail less renewable energy and really help continue decarbonizing the economy. So while I think this looks a lot like a duck, it lacks a certain something. And there are a couple of tools you can use to annotate data visualizations, but some of them are pretty straightforward. In this case, I decided to go a little bit outside of the R ecosystem and use MS Paint to provide a little flourish here. And there are ways to do annotations and drawings in R, lots of fun extensions to ggplot, but sometimes just doing it by hand is pretty fast. So a couple of takeaways. First one, really this is very exciting. Renewable energy has fallen tremendously in cost. And that's a really exciting thing because we're on our way to making our human civilization on this planet more sustainable. Maybe not as quickly as we would like, but we are making good progress. And so there's reason to be optimistic about the future of climate change. That said, the reasons to be optimistic, but there's still going to be a lot of challenges along the way, especially for professionals and people working in industry who need to deal with these changes and change how they do business, change what they invest in, really change a lot of what they're doing. On the R side, ggplot2 is far better than base R for plotting. The base R's plot function, it functions, but ggplot2 has an entire ecosystem and much more powerful and aesthetically pleasing defaults. So if you want to do data visualization in R, ggplot is a really good place to start and a really good place to stay. You can do so much more in ggplot2 than I've shown here. And on the data visualization side, regardless of what tool you're using, annotations and flourishes can make data visualization more interesting and appealing. Sometimes good data visualization is about displaying information in clear and concise ways so that people can absorb it quickly. But sometimes it's actually about getting people's attention so that they'll actually focus for a minute and look at the data. Because sometimes you have to break best practices in order to actually get people to engage with your content. So if there are any questions, I'd love them. You can also connect with me on Twitter, on LinkedIn, email. I've got a GitHub account too. Eventually these slides for this will make their way up there. I also, like I said, I wrote a book. So if you are interested, you can get it on Amazon or Barnes & Noble in both paperback and ebook copies. Thank you.
Thank you, Will. I do have one question with regards to the neck of the duck.
Yes.
You mentioned that a lot of it's potential waste with solar panels, trying to rev up at that time.
Yeah.
What does the future look like when it comes to actually kind of mitigating those issues?
Yeah, that's a great question. So there are a couple of cool ways of really sort of making the duck, if you will. And so part of it is just smarter scheduling and actually better forecasting. A lot of really sophisticated forecasting goes into figuring out what demand will be so that they can plan. Because if you know in advance that you need to turn on a generator, that makes it a lot easier and cost effective. It's usually cheaper and cleaner to start it up slowly. If it's unexpected, that's really hard. There's also a lot of really cool investments and research being done into energy storage and virtual power plants. And there, if you can move some of that peak, so if you can charge batteries during the day with solar and then discharge them as the grid is or as that neck, that evening ramp is occurring, you can flatten that curve, and that makes it much easier for the utilities to effectively use resources and keep the costs and carbon emissions low. There's also some really cool things you can do with frequency control services. If you can make the grid more flexible, it can respond faster with less risk of blackouts. One of the things that also makes the neck of the duck challenging is actually local weather patterns. Whether, if you have a small cloud go over solar panels, it's actually possible, if you have enough low-level individual data on solar panel installations, you can see a cloud move over solar panels as the shadow reduces their power output. And so there, if you have a surprisingly bad day where just a bunch of clouds suddenly show up, it's rare in California, but it does happen. That can make the back of the duck very spiky, which can be very challenging. So there are some really interesting things. We've got a great question about COVID-19 and if that's doing anything to energy usage. And actually, yes, in some places where there have been very high level lockdowns, we have actually seen energy consumption drop 10 to 20%, which is not, it's a close to silver lining. It's sort of like how when you're, if you're too sick to eat, you lose weight, which losing weight is sometimes kind of a good thing, but if you're sick, it's really more of a symptom than something that's actually good. But yeah, one of the things that is very interesting is the massive disruptions to our regular ways of life we're seeing right now, which will both make it easier and harder to make improvements on the climate change front.